When you add and subtract fractions, you need the denominators to be the same. Take a look at these examples. In this example, look, you're adding the numerator, and the denominator remains the same. In this example, you subtract the numerators, and you keep the denominator the same. So the first thing we're going to do is find a common denominator. To do that, I'm going to write out the multiples of 18 and the multiples of 45 and find a denominator they have in common, or a multiple they have in common. So I write out 18 plus 18 is 36. Then I take 36 and I add another 18. And I get 54. And then we're still counting by 18, so I'm going to add 18 to 54. I get 72. And I usually write out 5 multiples before I work on writing out the next set of multiples. So 72 plus 18, we get 90. So there are my multiples of 18. Now I'm going to write out the multiples of 45. So I start by writing 45. 45 plus 45 is 90. And look, we already have a match. So our least common denominator is 90. This is the smallest multiple that these two original denominators have in common. So what I'm going to do is I'm going to write 7 over 45, and the 7 over 18, I'll write it vertically, and then I'm going to change them both so that they have a denominator of 90. Once they both have the same denominator, it's a little bit easier to see which fraction is larger. Conveniently though, in this problem, both the 45ths and the 18ths have a numerator of 7. So both fractions have a numerator of 7. Well, if you divide a pie into 45 pieces, each piece is going to be a lot tinier than if you were to take a pie and divide it into 18 slices. The 18 slices would be larger. Each slice would be larger. So if you have 7 of these larger pieces, that's going to be more than 7 of these smaller itty-bitty pieces. So I do already know that 7/18 is larger than 7/45, but this will make it look nice and clear to see which is larger in terms of absolute value. 18 times what gives you 90? Well, 1, 2, 3, 4, 5 18s gives us 90. So I multiply 18 by 5 to get 90, which means that I also need to multiply 7 times 5 to get the new numerator. Next, I multiply 45 by 1, 2 to get 90. 2 45s gives you 90. And that shows me that I also need to multiply the numerator by 2. 7 45ths is equal to 14 90ths. So I'm going to go ahead and erase some of this work. And then I'm going to place the 14 90ths here, replacing 7 45ths. And then 35 90ths is equal to 7 18ths, so I can replace the 7 18ths with the 35 90ths. And then I copy this negative symbol, and I copy this subtraction symbol. And now that we have the same denominator, we just go ahead and record the denominator of our answer as 90, and then we can focus on the numerators. We're taking 14 and subtracting a negative 35. So when you see subtraction, I want you to change this to addition. So remember, we don't change this first number, and then we add the opposite. So 14 minus a negative 35 is the same as 14 plus 35. So I'll go ahead and add those. 35 plus 14 gives us 49. So we end up with 49/90ths. Now I know that 49 is made up of 7 times 7, and I can't break that down any further. The prime factorization of 49 is 7 times 7. So all I have to do is see if 90 is divisible by 7, and I know that 90 is not a multiple of 7, so this is as simple as this gets. You can't reduce it any further.